only the diehards are going to be watching this, is a derivation rule. And I'm going to go through it kind of quickly, but the nice thing about video is you feel free to stop it and kind of examine each step as you go to see why does that step make sense. So what we're going to do is we're going to start off by looking at the product rule, but we're talking about a function f times g. We're looking for the derivative of this function a defined as a product. So I'm just going to apply the definition of the derivative. Now you should note that every one of these limits is as h goes to 0, and it's not going to show up in every one just because of the software I use to write the equations. So here's our equation again, and this is just the definition of the derivative. F of x plus h minus f of x over h in the limit. But each one of those a's is in actuality this product. So I'm replacing a of x plus h with f and g, both of x plus h, and the a of x is f times g. Again, the limit h goes to 0. In the next, this is the strange step that appears to make no sense whatsoever. I'm taking the front end of this, and it's still here. The back end of it is also still here. And in the middle, I have subtracted and then added the same thing. That thing is f of x, g of x plus h. I subtract it, and then I add it. Ultimately, all I've really done is add the middle, but I have put some structure in there, and we'll see why that matters in the next. So what I've done in the next step is I've taken the first two terms, and we can see this maybe more previous clutter, put in some new clutter. So what I've done is I've taken the first two terms, and they share a common g of x plus h factor, which has been factored out. And in the second two terms, they share a common, get back up there you, they share a common f of x factor, which has been factored out in front, leaving us with the g of x plus h minus g of x. Now some of you might start to see where this is headed. I'm going to take this very long limit and break it up into two separate limits. All of them are over h. So I take the first piece of this, f of x plus h minus f of x times the g, and the second half is the f of x with the g pieces. In the very next step, with a little bit of maneuvering here, this g of x plus h is just moved down to be separated from the fractional piece. So it's really over 1, but I'm just moving it down as a factor. Same thing with the f of x, it moves down an outside factor. Again, all of these are limits as h approaches 0. And what you may recognize now is that the limit as h goes to 0 of this first piece is the derivative of f. And the limit as h goes to 0 of this last piece is g prime of x. As h approaches 0, I can do a direct substitution, and g of x plus h is becoming just g of x. So what we see in the final step is that this whole first piece in the limit is f prime. G of x plus h actually then just becomes g of x. We'll rewrite a new line. F of x stays out in front. It has no h's in it at all. And this is the g prime. Finally, in that limit as h goes to 0, and I should have done it in this step, this is not here. So we end up with f prime g plus f g prime. And that is the product rule, and it is proven.